Hello and welcome to the next session at the Zero Trust Summit 2025. My name is Philip Griffiths. I look after strategic sales for NetFoundry, and we're going to be talking about software defined perimeter version 3, expanding Zero Trust beyond humans. The SDP work has been part of the CSA for over 10 years now through various iterations, and we wanted to work on an update to the paper as part of the Zero Trust Networking subgroup within the CSA, and specifically look at taking some of the objectives that we see within the wider landscape of SDP, of zero trust, of identity, and expanding out some of the concept of where SDP initially started, client server based communications, and really bringing it into being the universal control point for any types of workloads, be it users, devices, AI agents, and more. So today in the talk, we're going to be looking at a few topics. Number one, why is software-defined perimeters more important than ever? Number two, what are the core concepts, architectures, and workflows? Three, how we expand beyond the use cases that we have traditionally been focused on of just users into operational technology, which actually is a big topic at this summit. I know I'm involved in another panel on that one, but also IoT, AI, microservices, multi-cloud, and more. Where SDP begins and other things like microsegmentation begin, zero trust, and those concepts, as well as implementation frameworks secure by default, and some vendor examples, and then looking at future outlook. This is all tied into the update that we are writing at the moment. It's currently in a peer review, getting lots of great feedback, which is helping us to create a better iteration of V3. So why is SDP, software-defined perimeters, more important than ever? Fundamentally, we have seen that the perimeter has continued to dissolve. The advent of cloud, a decade ago, of moving to SaaS, of edge and IoT, it just continues more and more to have a highly distributed architecture where there isn't really any more, or at least much less so, inside versus outside of the network boundary. And those non-human workloads are just proliferating more and more. And then fundamentally, the consequence of cyber attacks, of breaches, just continues going up and up and up and up. And fundamentally, even though we're spending more on cybersecurity tools, the actual damage from these cyber attacks continues to go up and up. And so we need to double down on the objectives of SDP, on the objectives of zero trust, to ensure that we have less static based perimeter models and static based trust models. Quick reminder for anyone who hasn't looked into it recently. What is SDP as a core concept? Well, fundamentally, we have the 5 core principles, which is we make our infrastructure and applications invisible. So both the resources shouldn't be able to be reached unless we've done authentication and authorization before connectivity, but then also the edge infrastructure should also be unreachable and unscannable. We ensure strong end-to-end encryption, mutual authentication. We ensure least privilege and deny by default with microsegmentation, reducing the risk of lateral movement. We ensure dynamic policies, identity, posture checks, context to drive our real-time decisions, and we have an application-specific security architecture. Now, fundamentally, when we look to thus build those communications, effectively we have a control plane, we have a data plane, and then we have initiating or accepting hosts. And that could be, they could be the same piece of software. One side could be initiating, one side can be accepting, but there's always going to be an initiator and an acceptor. Now, we have the control plane, it exists online. The endpoints mutually authenticate to the controller. They get given policies and services which are allowed. That enables the endpoints to receive those communications which are allowed, and that therefore enables, using the authentication authorization, the correct services to be able to communicate across their infrastructure while staying completely invisible, while ensuring mutual TLS and end-to-end encryption in the data plane with least privilege, with those dynamic policies, with that application-specific approach. And so that is our quick introduction to how SDP works. Fundamentally, this is part of the trend that we have seen in the last few years, and which is obviously a massive topic for the CSA around the principles of zero trust. In fact, there was quite literally a paper, I think 2020, specifically looking at SDP and zero trust. And there's a couple of quotes from a document which I agree with. That is, software-defined perimeter is essentially a network connectivity implementation of zero trust and zero trust principles, and that the fabric enables us to enforce these principles to the actual network packets. For me, this is one of the key transformations that we see taking place: the authentication and authorization of strong cryptographic identity before connectivity can be established. And this gets us to the most advanced implementation of zero trust strategy. Now, this is obviously quite different to a traditional networking approach where we use IP addresses, DNS, ports, protocol, etc. But fundamentally, traditional network characteristics, IP addresses, they are not strong identities, and they do not map to business applications. That's why it's so difficult with traditional networks to do least privilege and microsegmentation. And so fundamentally, SDP provides us a framework to apply zero trust principles to the network to ensure we do not trust, we always verify, to effectively treat the network as compromised and hostile, so that we do the authentication and authorization before any connectivity can be established, with mutual authentication and posture checks to ensure least privilege, so that every resource or access request is per resource, per session, connections or tunnels, and not just a flat underlay network, to assume breach and thus ensure services are completely unroutable unless you've done the authentication authorization, i.e., it doesn't matter if you're on the network, unless you authenticate and authorized, you have no ability to actually reach the resources, and therefore scan infrastructure, scan the environment, and find exploits to be able to attack with. To ensure continuous evaluation and use that policy information to make decisions to potentially terminate a connection, effectively dynamic policy, and then fundamentally to really focus on protecting our data and services rather than the network, rather than IP addresses. We are building our policies with attribute-based access control. And so fundamentally, we see a very, very strong alignment between software-defined perimeters and zero trust, with SDP really helping us to implement zero trust. Obviously, within concert of other tools, because networking and moving packets isn't the whole story of zero trust and its principles. One of the other areas that we looked at within the paper, V3, was expanding the toolbox. The previous iterations, V1, V2, really focused a lot around what's called single packet authenticate and first packet authenticate. And they were some of the original ways which were explored to do software-defined perimeters. In a nutshell, that is providing an initial packet which has some characteristics, metadata, and authentication to it, so that as it gets received by a receiving gateway, it can effectively default drop packets which have not had that authentication and metadata applied, and only apply temporary access for the connections which do present the correct first packet authenticate or single packet authenticate approach. There have been challenges with some of these approaches, though, particularly at scale, particularly around key management, around NAT. NAT kind of runs a world, or the world runs on network address translation today, particularly in cloud and hyperscalers, but also some corporate firewalls block UDP and other things that we initially used for doing FPA and SPA. You then have things like microservices. You have the requirement for consistent, performant connections, and also there's potential weaknesses in how SPA or FPA can be exploited by trying to flood the IP addresses of the receiving gateway. because although it may be dark, it still does have a public IP address. And then alongside all of those practical challenges, we have the fact that we need to be able to support these more modern use cases that we have been covering in the paper. East to west traffic and microsegmentation, Kubernetes, service meshes, etc., edge and IoT, cloud workloads, agentic AI, all of these things which are deeply challenging for static network configurations. And this was where we put a quite a decent amount of effort into the V3 paper in order to flesh out some of those use cases, and specifically where the challenges are for applying software defined perimeter for those use cases, and how we need to consider some updates to our approach in order to be able to apply software defined perimeters to these use cases. And so this was where in our paper we got onto the section of going beyond humans, and specifically client server, very traditionally, human initiated connections for software defined perimeter, so that we could think about software defined perimeter more as a universal connectivity control for whatever the use case may be. There was more or less 5 areas that we looked at. Well, then there's some overlap between some of these areas, but there's also some unique differentiators for each of them. The first was OT and industrial communications. And so this is how we can protect our critical infrastructure, which is a big topic as part of this summit, but also in the wider ecosystem, particularly within DoD and parts of the US government and within Europe, around how we protect critical infrastructure, how we enable industrial communications for our PLCs, for our HMIs, for our engineering workstations. And fundamentally, our objective is how we can apply software defined perimeter to that, even though there's some really unique characteristics for it. For example, some of the flows are incredibly low latency. We're talking like microseconds, not even milliseconds, with very deterministic communications. Some of it's very local, some of it's completely air gapped. Some of the very much an environment that's driven by safety first rather than confidentiality first. And so there's certain aspects that you have to consider in terms of how you architect such an SDP system so that it even can work in an OT environment. But we are starting to see vendors who are implementing these capabilities into those sorts of environments. One that immediately comes to my head would be someone like Siemens, with some of the capabilities they've been bringing to market for doing SDP and zero trust within OT environments. Almost at the other end of the scale, we have hybrid and multi-cloud, how we can enable communications from server to server. That might be legacy workloads, it might be a migration, it might be multi-cloud, but fundamentally there's some aspects around being able to support serverless workloads. There's aspects around being incredibly dynamic, the ability to scale, the ability to integrate with systems which are used in those environments. And that very much blends into the kind of service to service and microsegmentation use case, where we see compute and applications being run at massive scale with service meshes, with Kubernetes, with pod sidecars, etc. And again, there's a lot of scaling problems, but we also potentially have complete different identity systems in a traditional workflow. Maybe we're talking AD, or we're talking Azure AD, or Okta, or OICD, SAML, etc. In service to service microservices, well, now we're probably talking like Spiffy Spire or other PKI based systems, which really scale and stay very ephemeral. One of the edge use cases that we're starting to see more and more, and actually as we've been writing the paper, we've kind of been incorporating more and more, is agentic AI and APIs. The graph-based systems which are inherent to agentic AI are incredibly distributed, and that makes static network configurations hyper challenged by them. And so we have been looking at both in this paper, but we also have some other work coming out soon, looking at how we can apply strong SDP and zero trust principles to agentic systems, so that we don't have to reconfigure networks. We can tie strong identity to the workloads regardless of where they are, and thus make it much easier to manage, operate, and deploy. And then finally, how we can potentially look at applying SDP principles to IoT and edge fleets. Again, there's some overlap here into the kind of the OT and industrial realm, but has some of its own unique challenges as well, particularly very, very, very lightweight endpoints, which may not have much compute or capability to run software. Now, some of the interesting things that we pulled together and learnt across those use cases, which really forces us to expand the capabilities of SDP to be able to support all of these use cases, is identity. Identity is just such a central tenet to SDP and zero trust principles. Some people say identity is the new perimeter. I personally don't agree with that. I think identity is incredibly important. It is foundational, but fundamentally, the network should be the perimeter, the overlay network that is based upon identity, so that you do the authentication and authorization before connectivity, and otherwise those resources are unreachable and unroutable. And so this means that we need to be able to apply SDP and identity to those things wherever they are, not just users, but also the devices, the workloads. It could be a PLC, it could be Lambda, it could be a serverless function, whatever, wherever, we need to be able to apply those capabilities. Number two is that there are many use cases where locality and latency is critical. And so if you have issues, you need to ensure they fail safe and they degrade gracefully, rather than causing a collapse of the system and therefore for communications to not take place. This also means you might have to have a completely on-premise system. It might need to be able to run completely air-gapped. There's lots of nuances that you can get into there. The third, which I would say is just super consistent to everything we do at the CSA, is don't boil the ocean. Fundamentally, one of the things that we worked on a lot in this paper was a framework for how you map the protect surface, because you're not just going to go, hey, click SDP everywhere. You're going to go, well, let's pick my most critical applications and flows. Let's map out that protect surface. Let's start looking at how I can roll out this capability aligned to our business objectives, which really aligns into the fourth point around how least privilege can scale much better. And while we may start with deny by default, while that may be our security posture, the newer SDP tools, and I'd say also some of the zero trust networking tools, enable us to do flow discovery so that we can understand, or you can set up a more macro based intercept, see what communications are actually taking place, and thus get to a least privilege model. Observability is obviously everything, and that very much ties into identity. When we have strong identity as the source of what is communicating, we know exactly which identity is accessing which resources, at what time, for how long, what posture they have, and what data are they moving, and how much data is that. And that otherwise, that communication cannot take place, which is it reduces the noise in your SOC SIEM SOAR solution so much, because instead of just boom, you've got all these IP addresses that are trying to access the system. Instead, you know exactly which identity is accessing what and when. So much more secure by default, much more easy to manage and operate. And then also fundamentally, people and processes. You can have the best technology in the world, but if you don't have the correct governance and ownership wrapped around it, if you do not have the strategic alignment, then it's always going to be a challenge. We, as alluded to actually, we spent a bunch of time looking at a practical framework, but again, we didn't want to reinvent the wheel. There is a great paper from the CSA looking at mapping the transaction flows for zero trust. So we borrowed from that. We applied it to software-defined perimeter so that we can go through that 5-step process as to how we define the protect surface, what are our critical applications, because it's our applications and data that we care about, not the networks. How we then can discover and map those flows. And this is where machine learning can also potentially help us to map that, classify it, rather than to write policy from scratch. And therefore how we can move into business language rules rather than, hey, this IP address can connect to that IP address. It's hashtag engineering is able to access these resources, or at Philip is able to access sales resource. Like being able to be aligned to business language and business policy is the objective, and quite frankly far easier to actually manage for the organization. It also enables us to implement and iterate. Again, you don't have to greenfield everything at once. You can go application by application in a very intentful manner. And then that obviously plugs into, integrates with, and automates around the other tools and systems which are critical to our enterprise IT. And in fact, there's a whole section around how we align to the other wider enterprise IT systems, whether that's identity and access management, whether it's my security incident monitoring frameworks, whether it's my endpoint detection and response, etc., etc. All these tools have a place, and so we need to understand how they plug in. We then very much wanted to include a short section on secure by design. And this is very much a part of CISA, and the objective to make it so our applications are, well, as said on the label, secure by design. Now, funnily, Jen Eastley last year was talking about how we don't need more security products, we need more secure products. And this was kind of our objective. Like, software-defined perimeter is great. I think more organizations should be implementing SDP and zero trust networking tools and other things that help us to deliver these objectives. But wouldn't it be amazing? Wouldn't it be great if organizations, when they bought applications commercial off the shelf, they just had SDP and secure by design built into them by default? So that instead of having to build and wrap tools around our existing applications, instead the applications had built into them deny by default connectivity, identity-based access, strong authentication and mutual authentication, full auditable logs tied to that identity. This would just make it much, much easier for the organization. They would be able to buy and implement applications which were just more secure by design and by default. And there's also a wider and growing ecosystem that is implementing these types of principles, that's making it easier for us to build in secure by design, software defined perimeters, and zero trust principles into our applications. A whole bunch of that stuff is open source, and some other open source projects have already started incorporating those capabilities into their architecture. EdgeX 4.0 is a good example of that. And so next we started looking at how and what are the benefits of software defined perimeters, because fundamentally, if businesses are going to change things, they're going to implement things, we need to know what those benefits are. We broke those up into a few areas. I mean, fundamentally, in the paper, we've got a table that maps out, and it goes much deeper than this. But a broad overview has us being able to decrease risk within the organization by increasing security, shrinking the attack surface, and reducing lateral movement. There's a massive amount of operational simplicity that we get from implementing SDP, both in making our firewalls much simpler, our rules and our logic much simpler, but also way easier to enable connectivity and onboarding. Much simpler and better user experience. In fact, I was talking to an organization the other day, and they were switching from traditional VPNs to our tool, and they were saying that they were able to roll out around 90% faster. Rather than taking around 2 months to onboard a customer, they would be able to do it in about 2 days or something like that. So for them, it was huge. They would be able to roll out to their customers so much faster, and that is just a huge benefit that you get from SDP and zero trust overlay networks. The next one then is how it helps the business. It just becomes way easier to enable cloud, to enable AI, to enable IT/OT convergence. I mean, particularly in OT, that's one of the huge things that we see. Yes, you can apply this to secure remote access or machine-to-machine communication, but the connectivity between the plants and digital twins or AI workloads, it just becomes way easier. No need to reconfigure all the complicated underlay networks. It also massively helps our compliance story in terms of least privilege and microsegmentation, and there's definite decreases in cost from reducing the operational burden. And so for most organizations, software defined perimeter isn't about the cryptography or the tool or, hey, isn't this new sexy technology? Instead, it's around how do we make the environment less complex? How do we have less exposure? How do we just enable the organization to be much more streamlined in terms of how users access resources? We also included a section on looking at some actual implementations of these technologies, both a mixture of open source and commercial. One of them is NetFoundry and OpenZT, so that's a combination of commercial and open source, which actually is being widely adopted, including by Siemens in their industrial connectivity suite. Then you have a solution like AppGate. They were deeply involved in some of the earlier iterations of CSA SDP papers. That's a commercial solution. Then we have things like network infrastructure hiding protocol. That's a much newer solution. That also has an open source core. There's actually a paper from the CSA coming out soon on that. And then we have solutions like BIOS, which come from a hardware perspective, as to how you can take a piece of hardware and effectively wrap a software defined perimeter around assets. Or hardware defined perimeter. But the point is the principles align into how we're doing this. And in fact, in the annex, we have a section that is like a market study of looking at various solutions and how each of them map to the core concepts of software defined perimeters and to the various use cases that we see within the paper that we've written out. Because again, various tools have various pros and cons, strengths and weaknesses. And so then we had the conclusion for the paper, very much how our objective was to having identity as the universal control point regardless of the workload. Yeah, it's great to be able to apply it to humans, but the world is much more complicated than just client server communications, and we should be able to apply it to any and all use cases. This enables us to really provide the framework to zero trust networking principles, and zero trust in general, so that we can use SDP and microsegmentation to apply least privilege and all those wonderful principles to any use case, and that we have that framework of starting with your critical flows, using the implementation framework, and being able to embed SDP concepts and patterns into our architecture and products in the least disruptive way possible. Because fundamentally, this isn't science fiction. This is all available today. Whether whatever use case you want to apply it to, we have those capabilities. And our objective with the paper was to demonstrate and educate people on how much easier it can be for them to do it. It has been a pleasure presenting to you today. If you have any questions on the paper, feel free to get in contact with myself, either via the CSA or LinkedIn or whatever. We still do have some comments coming in for suggestions on the paper. Obviously, when it's published as well, we'd love to have feedback for maybe the next iteration or other papers we could work on. So thank you very much for your time today. Looking forward to hear from you if you have any thoughts or feedback. Thank you very much.